This is the short version of titration maths. This is what I would be expecting you to do every time we give a question. As I say, you are going to have, I'm recommending that you do this in the extra pages at the back, and you can refer to it in a question. So if you have like question I in a box, you can write, see extra pages at back. I'm obviously thinking about this all of the time in terms of new exam paper setup. And it might be that that's all you write in the question box, and you make your examiner go back. And as long as you've set up the annotations correctly, you might not even need to write anything else. You just do your maths. That should work. So, if there's a point number 2, and this is its box, you can write the exact same thing. Point number 3, as long as you kind of recognize this is all, they're looking for all the different bits to the titration maths, have at it. Okay, you will have to look, that is definitely a thing. Within the question, there could be a previous part that you need to do your data table, or there could be something in the blurb where all the writing is, and the blurb might be a page away, page backwards, so you're going to have to look. That is a definite thing. So you definitely will need to write your equation. You may have had to balance it. I'm not going to do that here. The part of the equation that we're really interested in are our reactants. So the things to the left-hand side of the arrow has to be balanced. You can use wrong numbers, and as long as you use them correctly, that doesn't matter. So my headers are always attic and basement. My attic is obviously my burette. The number in the question that you're going to be looking for is going to be a weird number. It is going to be like 0.1, 0.2, 0.3, 0.4. It may be that you have to calculate it yourself, but it's going to be what we call a weird number. Your basement is going to be the thing that you used with the pipette. It is going to be a perfect number, so it's going to be something that's going to be 0.0, so it's a perfect number. You may decide that you want to write in what was in our attic and what was in our basement. So in this case, it was going to be HCl, and it was our primary standard sodium carbonate. You need to find a volume, big M concentration, moles per litre, and the ratio for the different parts. So when we did our titration, it was 24.0 centimetres cubed. You did your calculation, and it was 0.1 big M. Looking at our equation here, there's nothing written in front of the sodium carbonate, so that means the ratio is 1. Going across to my HCl, my ratio is 2 here. I am not going to have a value for this, so some question somewhere along the lines is going to say, concentration possibly in moles per litre in big M. If it doesn't matter. Just do this maths and we'll see, can we pick out what we need to answer their questions. So, but this will be a question mark. You should only ever have one of these spots filled. It may be that you had to do a calculation to get to this point. So you may have to calculate this part yourself, but it is possible. And if in doubt, you can't do that calculation, or you don't know, didn't realize what it is, you just put a number in here. Pick any number, and as long as you use it correctly, you will get marks for your maths. You're not going to get all of the marks, but you'll definitely get some. So when we did this, we had 40.2 centimetres cubed. Okay, at this point now, we're going to this W. So the point of the next two pieces of maths are going to be this W, which is going to give us a big M value, and we're going to do a conversion factor for grams. So they are our kind of two big pieces of maths that we're going to do. So again, you need to recognize that in this piece of maths, we have a weigh in, and we're trying to get to all of these little blue points that are appearing here. You need to recognize that we start at this blue up here, and then we are following the pathway. So we have, or hopefully you will have steps that you can figure out. So this here is our weigh in, or at least that's what I call it. So it's 0.1 big M. We know when we go down, we are dividing, and we're trying to get it into moles per centimetre cubed. So to do that, I'm going to divide my number by 1,000. On the next step, we're going up, and ups are always multiplications. and you are going to be multiplying by whatever your titer volume is, is for the sodium carbonate. So if you want, you can just draw a dashed line here for yourself. You can put sodium carbonate here so you realize that we're dealing with those numbers. And when we cross over the flat part, we're going into HCl world. Okay, when we do this multiplication by TV, you're going to be in moles per whatever your titer volume was, which in this case is going to be 25 centimeters cubed. We're going to use our ratio, and the ratio is 1 is to 2. And when we get the answer here, it's going to be in moles per 40.2 centimeters cubed. We're coming down. So the down is a division, and we know down at the bottoms of everything, we are calculating moles per centimeter cubed. So here, to go from 40.2 centimeters to 1 centimeter, I'm going to be dividing by this titer volume. And then finally, the last part, we're going up. I'm trying to find my big M value of my HCl. So I'm going to be multiplying it by 1 because I had 1 centimeter cubed here, multiplied by 1,000 to turn it into moles per 1,000 centimeters cubed. So we start our maths. So we take 0.1, and I would always recommend that you expand this. So it's 0.1 moles in 1,000. You just said I'm going down to what's in moles in 1 centimeter cubed. So I'm going to divide my 0.1 by 1,000. That's the piece of maths I'm doing here. And the answer to that comes out at 1.1 by 10 to the minus 4. I'm going up now, so I'm trying to find moles in my titer volume. So here I'm going to be multiplying it by 25. So when I put that into my calculator, I'm getting 2.5 by 10 to the minus 3 moles. I use my ratio, so 1 equivalent is 2.5 by 10 to the minus 3. 2 equivalents is going to be double that, so 5 by 10 to the minus 3 moles in 40.2 centimeters cubed. So in questions, they may have, so this flat part, they'll be referring to the end point. So that's what this flat part is, it's the end point. So moles of each reactant at the end point. So with this then, 5 by 10 to the minus 3, we want to, in 40.2, we want to find it in 1. So I have to divide by my titer volume, so 40.2 in this case. And when I do that, I end up getting 1.244 by 10 to the minus 4. Now, this is the first time in the maths where we are going to have loads and loads of digits in the calculator. You have to put it to 4 significant figures. Have to do it. So now we have moles in a centimeter cubed of HCl. I want to turn it into the big M value, so I'm going to multiply it by 1,000. And when I do, it's just going to turn out to be 1.244, and again, 4 significant figures. You're going to finish this maths for me all of the time. So we have this moles. We are going to, so we have moles in a litre. I want to transform it to grams in a litre. You need to recognize if we want to transfer it into grams, we have an MR calculation that we have to do. That's the conversion factor one, the molar mass one that we want. So we use our long form of the periodic table in the maths tables, and this is what we get. When we add it all together, we get 36.458. We want 4 significant figures, so we make the 8. What does it do to the 5? So when we do that, it's going to be 36.46. So up here I have 2 choices. I can go 36.46 grams in moles underneath, or I can go moles on top and put 36.46 grams underneath. So we're starting with moles here. I want to end up with grams, so I need my moles to cancel out. So for that reason, this is going to be my choice, because if I did it this way down here, then I would end up with moles squared over grams as my units, and that is not what it's going to be. Okay, so we just clean this up a little bit. And we go, so it was 0.1244. We are going to multiply it by 36.46 grams over my moles. So I'm getting rid of this and this. And when I put it in, again, 4 significant figures, I get 4.536 grams per litre of HCl. Now you need to recognize again, when you go back into your text, it's these little boxes up here that we've been drawing in. What are the things that they could ask you to do just in terms of the titration maths? So to reiterate again, and I'm going to leave this guy kind of big so we can see it. Okay, so a question they could ask would be find moles of sodium carbonate in 1 centimeter cubed. And again, you might just be writing in the box where they have this, see extra pages. So you can do that. Your examiner then would look at it, and as long as you have it all annotated correctly, even with like just these parts, then, they know what they're reading and they can mark it accordingly. Sometimes you don't have to tell them. So if you're in doubt, just say, see extra pages. Or if you know and you're confident, you would just write 1 by 10 to the minus minus 4 moles in a centimeter cubed. The next question might be find moles of sodium carbonate at your endpoint. So you're following along your W, and that is going to be this bit up here. So you are now writing 2.5 by 10 to the minus 3 moles here per centimeter cubed. If you wish, you don't actually have to. I think, you can just write the C extra pages in every square, and then it's up to the examiner to find it. They might ask you to find moles of HCl at your endpoint. So that's the flat part. You use your ratio like so. So that's here. So again, you could write just the extra pages, or you could just write 5 by 10 to the minus 3. I think you need to write the C extra pages in every box irrespective, so that they can go back and they can see your workings out. The next question that they might ask is find moles of HCl in 1 centimeter cubed. And then we're at this portion down here. So 1.244 by 10 to the minus 4 moles in a centimeter cubed. And again, we might be saying see extra pages so they can see how you kind of worked that out. And then one of the final questions might be find concentration of HCl and in a big M value. So that would be the 0.1244 big M. You say thanks very much. They might ask you find concentration of HCl in grams per litre, which brings us to this part. And as they say, skip to the end, 4.536 grams per litre. Okay, and again, you might be writing C extra pages because they more than likely are going to give you marks for this little part of it. So you need to make sure you've shown them that. Again, just going back, because we didn't say when I wrote it, this part here, you need to make sure you're showing them these numbers, because if you write something wrong here, they will call it a slip. So they will give you possibly 3 marks, take away 1. So it might look something like this. But if you just give them the wrong number here, so you might write 36.48, then that's going to be a big fat 0 straight away. Okay, so there's a technique to it. You've got to be patient. Okay, so it's the W, and it is the data table, and it is the grams conversion factor has to be put somewhere. May the force be with you.